322 over 262 over 322.
Guys, who told me that the p hat was p over n?
No, it's
X over n, right?
it's x over 262 over 322.
It's x over n, but you had p as that number, which is really x, right? The 262
over 322.
I told you it was
All right.
0.89.
So let's try this out together. Here we go. We got this first part. So we know it's a two-tailed test. Depending on what mood I'm in, I might be nice and not even include t as a possibility, or I might. But we should remember that NPQ, I never use t-scores. It's either z if it's normal or nothing if it's not normal. So here I got to check NP and NQ. 322 times 0.85. And whatever the hell, that's greater than 5. Right. Whatever you guys got. Is that cool? So far, so good? So I know it's normal. I never use t-scores, so I can use z-scores for an NPQ problem. I never use t-scores because I always know the standard deviation, because I can create it out of p and q. Rejection region. And let me see if I can make this point in general. The claim could be either the ho or the high. You with me? The high is always kind of fighting against the ho. The high is saying, since the ho always has what in it? What's the ho always have in it? Equal sign. So the ho is cool if it's anywhere close to this, because he thinks it's equal to this, greater or less or equal to directly. You guys with me so far? So the ho is cool with anything here. The high, not high, Jeff, bigger, wants to be out there. He wants to sample them out there, because if it ends up way the hell over here or way the hell over there, how likely is it that the real population is right here? Not very likely. So if somebody had a claim that the average age of students' growth spot was 40, we go, well, you're crazy. We take a little sample and we get an average age of 26. We do the test and that shows up that is pretty damn far apart. So I've totally busted that claim. Can we say that the average age is 26 now? No. All we can say is that it ain't 40. It is definitely below 40. We could even use correct grammar, but we'll stick with that. So that is actually the heart of a hypothesis test. The high sets up the rejection region always, because this is the one that doesn't have an equal sign. It's showing you where you got to end up to show evidence. So I've got to be up there, down there. In this case, it's a two-tailed test. The rejection region is now defined by alpha 0.01, two-tailed test. We can use z-scores. What would the z be for that?
It's going to be 2.576.
I like it. If you looked at the T chart, you got 2.576. If you looked in the Z chart, you'd actually get 2.575. It's a little more precise on the T. Now, a lot of you guys were concerned about how to write this in words, but the minute you shade that in, you basically showed yourself how to say this. I mean, how would you describe that region to somebody? You'd say, if it's less than this,
Reject that.
so if Z star is less than that, or if Z star is greater than that, that's evidence that it can't be this or something around this, right? It's so freaking far away up there or down there that that's crazy. That's the whole heart of hypothesis. I know there's 5 steps, but step 3 and 4 are the key steps. What's far enough away? How far did I make it? So here you reject the ho, support the high. Those go together. Those aren't 2 options, by the way. If you reject the ho, you automatically support the high. Those go together. If we don't, we fail to reject the ho. We fail to support the high. Okay, how are we doing so far? All right, I think we're good up to there. And then I think the next step, it's a little confusing, but don't make this more. You don't need this formula. This formula is kind of, you can use it if you want to, but sometimes we're like, what the hell is X? All you got to do is look at your sample and make a percentage out of it. If I talked to 80 people and 11 of them said that they like Brussels sprouts, then 11 out of 80. That's my p hat. That's what I saw from my sample. Make the percentage. Don't overthink that step. So what do we see in our sample?
262.
Yeah, 262 people out of,
322.
and that was 0.8.
0.81 degrees.
814. Cool. Cool. So that's p hat. And a little reminder, what is p? Because I need that for my z star formula, right?
0.85.
Yeah, p, you can always look back to the claim. Well, not the claim, but the hypotheses. Whatever that number is in there, that's going to be what you're assuming to be the p. So again, behind this whole thing is, all right, let's say that's right. That's behind this whole thing. So we're assuming that that is correct, that the null is correct. So what's q?
0.15.
0.15. So now you got everything you need to plug in there. You need a lot less for PQ problem because you create your own standard deviation from those things. So Z star, here's how you put it in the calculator. P hat was 0.814 minus P is the 85%. If you have the old TI, it doesn't extend the square root symbol. If you have the new one, you're golden. Just make sure the square root symbol extends over the whole thing. If you have the old one like me, it opens a little parenthesis for you. Do not close it until you want to be out of the square root. So the biggest mistake I see is people do this. Times, oops, you came out of the square root. It stops right there. So just don't close it. Say 0.85 times 0.15 divided by 322. Close it. So you can put the entire thing in the calculator. It doesn't have eyes. So you have to tell it this is the top. And you have to tell it this whole thing is inside the square root. That's how you put it in all at once. Now it's not impossible to get a z-score of like 50, but that normally means something went wrong with your calculation. What do you guys get with this?
Negative 1.81.
Cool. And where is that on the picture here? Negative 181. I made it down to here, maybe. So did we make it far enough away?
Yeah. No, we did not.
No, we did not. What's far enough away? The shaded part. And we only made it right there. So did we reject the null?
We failed.
We failed. We didn't find enough evidence. This is completely acceptable to be there. So let me get you guys to understand. Anytime I take a sample, am I going to find the real mean or the real percentage from a sample? I will put money, a lot of money, and I don't do that often because I know the probabilities. I'll put a lot of money that it won't be the same. Because you're taking a sample. It's not going to be exactly the same. There's going to be random variations. You're going to hit a little bit higher, a little bit lower. So of course it could be below or above naturally. What this test showed is it's not so unlikely for it to be there if that really is the middle. So if that really is the middle and we got a sample here, that's not that weird. It's still, one way to look at it is it's still within 2 standard deviations. But now we know that's in the past. We have a lot more precise way of looking at this. Okay, how are we doing so far? So that is kind of acceptable. It's possible, right? Random sampling. I just happen to pick a bunch of, what was the whole point here? 322 people where not as many of them said yes to this, right? Just happened to be that way, and that's fine. So here I can say, fail to reject the Ho. So I fail to support the high. Which one of those is going to help me write the conclusion? Which one of these, the first or the second?
First.
Why? Because the claim is the HO, right? Since the claim is the HO, I'm going to use this wording to write the end. That right there is like another big part where students have trouble. How the hell do I word this thing? Well, we failed, so we have not found sufficient evidence to use these words, right? because that's what the claim is. So we have failed. We didn't make it far enough. We have failed. We have not found sufficient evidence to reject the claim that, now I forgot what it was.
Us too.
Yeah.
And that's fine. I mean, there's no part of this that's like a memory check. You know, do you remember now without looking at it? No, screw that, scrap. Look back at it. I'm like, I don't remember that. That the proportion of professors, percentage of professors who would be impressed by taking a 3-week course and passing it is the same as 85%.
He didn't even write
Would it be wrong to say that if we fail to find evidence that the portion of professors is the same as the students who felt that way? Or you need to have all that extra information?
Well, we have not found sufficient evidence, you need that part, to reject the claim that the percentage of professors, and you can just say the percentage of professors who would be impressed is the same as the students. So let me take a step back here. What does that mean then? Can we say that the professors, a different percentage of professors feels that way than students?
Yeah.
We failed to reject that they're the same. We failed to reject this. So I can't say the professors is not the same as 85%. Now, I'll still have students who say, well, I found freaking 81%, dude. What the hell's your problem? And I don't care, because that came from a sample. If you're trying to say something about the whole population of professors, it's not enough. You've got to be so far away. How far away? This far away. To show me that your sample actually means something. That it's not just due to random sampling, variation. That's not far enough away to say, holy crap, that's weird. Okay. So the very last question I ask you is, how would this be different if alpha had been 0.1? What would change?
The Z-score.
Yeah, from step C, right? The Z-score wouldn't be 2576 anymore. What would it be?
Lower? Or closer to?
Closer to, so it'd be higher.
It's going to be 1.645.
Where would negative 1.81 now be?
In the rejection.
In here, we would have rejected. So in this case, we would have rejected the claim.
It seems simple.
In this case. In this case. So, and again, this goes back to statistics being the most honest branch of mathematics. It says, it's up to you to tell me what's important. It's up to you to tell me how far away I need to get. Because one person might say, well, you got to get this far away. The other guy says, no, you got to get further than that. So one guy might be cool with it, and the other guy would be, no, you didn't succeed. It all depends on that alpha, and that alpha is set by experience. Like an extreme example I give is at a nuclear plant. You're testing everything, you're seeing how far out of normal things are, and it's okay for something to be a little hotter or a little colder. But when they get outside of your benchmark, and of course you're going to set your benchmark probably pretty damn low. Because you don't want to wait, well, now it's 8,000 degrees, is that a problem? No, that's probably a problem. So you want to set it pretty low. Are you with me? So it all depends on the situation and how bad is it to make a mistake. Okay. So now try out the second one.